Hello and welcome to Tattva Conversations and Explorations. For our second episode on biology, we sat down with Professor Ramaswamy Subramaniam. Professor Ramaswamy is an Indian-American structural biologist. He is currently Professor of Biological Sciences at the Weldon School of Biomedical Engineering and Director of the Bindley Bioscience Center at Purdue University. He was a senior professor at the Institute of Stem Cell Biology and Regenerative Medicine inStem from 2009 to 2019. He works in close coordination with the Department of Biotechnology and other ministries of the Government of India. We talk about his understanding of what biology and evolution are, how social media is redefining how scientific knowledge is conveyed to the public, how biology is driving the hard sciences forward, the presence of an elitist mindset in the scientific community, and what makes it counterproductive. We hope this conversation can help the listeners see the Tattva, or the true essence of biology, and its potential to help us understand how life came to be and the various ways in which it evolves with and through human beings, as well as all other living beings. Hello, Professor Ramaswamy. Welcome to Tattva.
Hello, nice to meet you and nice to do the podcast.
Great. So, let's just dive into it. I have prepared a bunch of questions for you. I'd like you to explain to me what is biology.
So biology is a very general term used to define anything that is living or is capable of replicating, right? So the way you could define a system that is biological and non-biological is actually a very simple way to think about it. The way I think about it is, if you leave a dead fruit, it will rot. What does that mean? It reaches an equilibrium with its environment if you don't do anything. What is life? It is able to separate itself from the environment. It might use energy, it might use other things, but maintains an equilibrium that is inside and that is different from the outside. Any system that can make the energy and do it themselves, to do that in some ways is what one would call life. Often people think that the ability to self-replicate without help of anything else is life. But that's a very poor definition, while it might be true, because if you think of a virus, we can argue whether it's living or non-living. It cannot replicate itself, but we still call it as part of biology. I'm just differentiating what definition people think for life is from what biology is. So biology is the study of organisms, is the study of things where there is an internal equilibrium that can be maintained in the absence of the external equilibrium, right? And can make the difference. That's what I would call biology. The most important thing to remember is biology still has to follow all the laws of physics, chemistry, that exists. So it cannot do things that are beyond what physics and chemistry can do.
Okay, I think this was something very different about biology, something, of course, I had never thought of. And from my research also, nothing close to this, as far as I can remember, came. So if I'm understanding you correctly, what you're saying is something that sustains itself. Is that a good way to put it?
Sustenance is a very funny word, right? Sustenance means it can make its own food, it can live. It is working with the environment, part of the environment. It is interacting with the environment, but it has an internal equilibrium that if you just let it there, it just will not become part of the external equilibrium.
And then this internal equilibrium. So I am a human being. So I have never lived the life of a cockroach or a frog. So inside of, this person, this being, this equilibrium is in terms of what? Like when my lungs also functions and my digestive system also functions and my mind is also all right and things are functioning okay. What is equilibrium here?
Let's make it much more simpler. Let's not take up a human being or a cockroach. Let's take the simple organisms. That's much easier to understand. A single cell organism like a bacteria, right? If you think about a bacteria, inside the bacteria, there are things that are happening. Outside the bacteria, there are things that are happening. It is the study of biology as far as there is a distinction between the inside and the outside. That does not mean it's not interacting. It will take glucose from the outside. It will take oxygen from outside. It will take water from outside. And it will give things outside. Both are happening. Yet, inside and the outside are different. When do I say it's not biology anymore? When do I say it's dead? It's when the bacteria will just become part of the outside, right? When it cannot actually interact with the outside world, take things from outside, give things outside. So there is no inside and outside. The inside and outside become one. It is inanimate, and it's not biology any longer.
When we spoke to one physicist, he says everything that is around us is the domain of physics, but not everything is the domain of biology. So perhaps what he also meant is when things die, perhaps they're no longer, he gave the example of a rock, that rock is not the domain of biology. Is he right? He's right in saying that, right?
He's right in saying that, but this is I studied physics. I studied physics before I became a biologist. There is this fundamental argument that what is the most fundamental science, right? The idea is that if a chemist would say everything is made up of molecules, and since the study of molecules is chemistry, everything is chemistry. And the physicist would say, well, fundamental principles that govern the laws of nature are all physics, therefore everything is physics. I think of biology slightly differently. Physics and chemistry are what I call hard sciences, right? Where you are beginning to understand things from first principle. So biology is nature's way of engineering, where it's using the principles of chemistry and mathematics and beginning to create things that can do things using the laws of physics and chemistry.
Very interesting.
Right? So to me, biology is more of an applied science than a basic science, even though in schools we have taught physics, chemistry, biology, and mathematics are the four basic sciences. Biology, really, we think of it as a basic science is a fallacy. And as we do more and more research, as we do more and more understanding in biology, biology is the way by which nature applies the laws of physics and chemistry. It might be different from building a bridge, right? But this is building a way of maintaining energy, using atoms, using whatever you want. I can give you examples of quantum mechanics that happens in biology. We can talk about anything you want, but what does biology? It's using the fundamental ideas of physics, laws of nature, but engineering something that can maintain an internal equilibrium that's distinct from an external equilibrium.
So now if we go back in time, way back in time, when the first cell divided, from what you're saying, perhaps at this point that the first cell divided, the laws of physics and math in nature had been laid out, and the time had come for them to be applied to see how their interaction now plays out.
Yeah, I mean that's a very nice way of putting it, right? It is, but it is not intelligent engineering. It was an accident of physics and chemistry that created a self-replicating set of rules that happened, right? But remember, they have to follow all the rules of physics and chemistry. It just so happened over millions of years that you brought together a set of molecules in a particular fashion, in a particular environment of temperature, pressure, whatever, that then decided, hey, you know what, there is an inside and an outside. But we do that all the time, even now we engineer that all the time too, right? I can engineer a balloon and pump air, and the pressure of the air inside is higher than the pressure outside, and the balloon's rubber keeps it, the inside and the outside separate. Similarly, what you did is you put a bunch of molecules inside, which has the ability to around with a membrane around it. And now what happened is this guy decided, you know what, I want to make more of myself, and I will steal energy from the outside, but I will make more copies of myself. So that's exactly what you said, except that I just want to extend it to say the idea of inside and outside is not new. The idea of something that can replicate itself also is what happened. That was the engineering, but it was not design, it was an accident.
Right. Accident is the first building block of evolution. This is also something I've picked up from a film. So there is an equilibrium inside the balloon, and outside the balloon, it has its own equilibrium. Now, in terms of equilibrium, these two are different from each other, but for itself, it is in balance. It is reconciled, all the forces, right? And that difference keeps the overall equilibrium in some sense, is it?
Yeah, you could change both and affect both, right? I could keep increasing the pressure of air outside, and my balloon will shrink because the inside pressure and the outside pressure will become the same. I could make the pressure outside less, and the balloon size will become bigger without any inside having nothing to do with it. So there is this inside and the outside, and then there is equilibrium, and you could change both. Now think about life. You could change the outside, but what the cell will do, or the bacterial single cell will do, is to say, you know what? The temperature outside is changing. I don't like that. So I'm going to change things inside to make sure that I compensate for it. But a balloon inside cannot do that. You see the difference between life and inanimate, even though both a balloon and a cell covered interacting with the outside. This guy says, I like what I am, my current equilibrium I like, and I'm going to modify things to maintain this equilibrium.
Yes. Right? I totally get it. So what we are saying is that the one which has life can create something which resembles life, but it might not be able to sustain itself the way I can sustain myself. Secondly, I also want to know from you, it's when something dies, say, it is spiritually speaking, they say it's gone back to where it comes from. But when something dies, like when you gave the example of a fruit rotting, and its equilibrium that kept it as a fruit, that gets shaken, it takes another form. So some kind of transformation is one word that is, I think it's catching up a lot, that it's nothing is dying, it's just transforming. Because then also it is affecting the environment that where it is rotting.
No. It's not different, right? Now, imagine I poke a hole in a balloon. The pressure inside and outside will become the same, right?
Same.
Now, there is no inside and outside. When something dies, what happens is slowly the inside and outside become the same.
In terms of what? Here, in the case of a balloon, it's simple.
In terms of becoming carbon, when you put heat, I'm going to go back and forth between a big organism and a small bacteria to make some things easier to understand.
Sure.
What happens when I put you in a sauna? I'm heating you up, right?
Right.
When I heat you up, immediately your body reacts and says, I'm going to make sweat and cool my body. So my temperature inside is still going to be different from the outside temperature, and my body is going to work very hard. Now, what happens when you die? And you don't do that. Your inside temperature and outside temperature becomes the same. So you become in equilibrium with the external world. That's what I mean, right? The ability not to maintain your internal equilibrium is what makes it different.
Very interesting.
It just becomes to the equilibrium, right? So when fruit rots and it is dead, because then what happens is other bacteria can eat it. If you don't do anything, it will slowly disintegrate. All the bonds will break. It will become carbon, nitrogen, oxygen. That's what it's made up of, right? It'll just become carbon, nitrogen, oxygen. It's okay. There is a more chemical way of thinking about it. We are talking about a physical way, right? There's a chemical way of thinking about this. Chemical way of thinking about it is a little slightly different. You can think about carbon or nitrogen and call it organic nitrogen or organic carbon, inorganic carbon or inorganic nitrogen. A life process maintains an organic carbon, right? So for example, one of the biggest challenges in the world today is how do you make, there is so much nitrogen in the air, biology cannot use it because it's inorganic nitrogen.
Right.
How do you make it into organic nitrogen so that biology can use it? So you see, there's a chemistry way of thinking about it. Initially, we talked about the physics way of thinking about it. But when something dies, what happens? It just goes into this equilibrium that it can become it initially starts off as organic. Leave it alone, it will become inorganic forms of the same thing.
Thank you, Professor Ramaswamy. This was very insightful and very interesting. So in some sense, sounds like all things that are organic are made up of what is inorganic because that's what we are disintegrating into.
Well, this organic, inorganic is a definition we have made in our head. So what you're saying is true, but that is your definition. What is organic and what is inorganic is a definition we made. Organic, something that can sustain or be used by nature or biology. Inorganic, that cannot be used by biology. That's the definition we made. So you're correct as far as you understand that it's a definition that is made by us. And imagine there is a completely new life form that will begin to use N2 and not NH4. Will N2 now become organic?
I guess so.
You see why the policy is said?
N2 will then become organic. Yeah. So, I think we have hit at this definition of what biology is from a couple of different angles. I hope it creates a nice little picture of what biology is. The other thing what I wanted to ask you is, in what ways is biology different from these other sciences, the hard sciences that you were saying? In what ways is biology different in terms of how it sees the world, how biology sees the world, which means how a biologist sees the world, and the picture then they then bring home of what all of this is and who we are?
I think it depends on which biologist you talk to, okay? Because biologists are not a single type of species, whereas physicists and chemists are more or less a more uniform type of species in terms of their thinking, right? So I think of biology as I said, engineering, where I say, and if you think about my own research, if somebody asks me what research you do, the answer I give is, I try to understand biology from the first principles of physics and chemistry and make mathematical models so that I can predict what would happen. What is biology for me? Biology is that using knowledge of physics and chemistry and engineering it, right? So it's nature's engineering is biology. So for me, biology is an applied science, not a basic science.
Right.
Now, if you ask me suppose you ask what's an electrical engineer's perspective of physics, that's a very mute argument, right? So I can tell you what the biologist thinks of the world, but it has nothing to do with physics and chemistry, because physics and chemistry are the basic laws which govern all of biological phenomena. But the way, when we think about as a science, what biology, physics, and chemistry, and what the distinctions are, and what we know, where is it, what is the relationship, where it goes, I think about this slightly differently. Till in the early 19th century, was the time of quantum mechanics and the physics, right? It was all large amounts of development in physics. And this large amount of development in physics and chemistry allowed humans to become more curious about life and how plants grow, or humans fall sick, or, you think about the observations that you make around. Remember, most of our initial curiosity-driven questions came from observing outside of us. Yeah. We observed the stars, we observed the planets, we saw fire is hot, water is crossing flood. We never asked the question of what am I made up of. We thought what I am made up of is more my mind and spirituality. We didn't think of it as phenomena in scientific processes. In the last 50, 60 years or 70 years has been very interesting, because we are now beginning to look at this interesting engineering that nature has done and ask, hey, how does this work? How does that work in biology? How does a cell replicate? How does a DNA replicate? How do I maintain this equilibrium? What are the different ways by which nature is engineered? And we have used physics, chemistry to understand, hey, I know what it is. It's a carbon-carbon bond. Chemistry knows that. Oh, biology is made up of carbon-carbon bonds. Oh, if I take 2 amino acids and I want to make a protein, I have to just remove a water and make a bond. So what we did for a long time was explain what happens in biology, the engineering, right? And say how it works. This is a nice corollary will be this, right? Think about the fact that suddenly you have never seen bridge. We didn't know how bridges were made. Bridges across a river. You land in this planet, somewhere you find these bridges, and you say, and you're a smart thing, and you say, what are these bridges? So you begin to ask questions. Why is the bridge standing? How is the bridge able to carry this load? Why are these bridges for people? Why are these bridges for trains? Why are these bridges for cars? You ask all these questions, and then you understand. That's the first step. So that's what we've been doing in biology for the past 50, 80 years, 100 years. Now things are suddenly changing, right? We are saying, okay, I know all of these principles in physics and chemistry, and I build a bridge. Now, I'm talking about a biology bridge, right? I'm not talking about a bridge now. I'm saying, how can I use this understanding? Now, when we begin to do that, we are saying, there's fundamental problems we're having, right? I thought this is the chemistry that how this worked, and I explained it, but I can't use that chemistry and engineer anything. I'll give you an example that you will relate to. Let's use the bridge example. If you want to build a bridge today, because you know all the physics and the chemistry of how bridges work, right? Because you did all this research. You will go to an engineer and say, I want to build a bridge. And the engineer will ask you a bunch of questions. what is a bridge for? It's going across a river, or it's across, across a railway line, or what is going on top of the bridge? How much weight will it carry? What does measure the soil properties, and say, okay, I'm going to build a bridge for you, because they know all the physics, they know all the chemistry, they know all the mathematics, they write this, design it, and they build a bridge, and bingo, the bridge works, right? You go and say, coronavirus happened. I have a new viral infection. I want to design a drug. What do we do? Oh, I will try 1,000 molecules, throw it at this, and see which one works. Right? We do trial and error. We don't know essentially what that means. And then we say, oh, I found a drug, and we call it science. It's really not science, because we calling trial and error science now, right? I tried 1,000 things. Would you go to an engineer who says, well, you want a bridge for cars to go, I'll build 1,000 bridges and see which one's cars. Why do we accept that from biologists? The reason is we don't understand enough of the physics and the chemistry of how biology works. We could so far explain in things in biology that the physics and chemistry we knew could help us understand. But we are beginning to make observations in biology today that the current physics and chemistry cannot make us understand. So we need to now go back and say, what is the chemistry we don't know that nature is used to do this? What is the physics that nature is using to do this? Right? So think of this as a cart and a horse problem as well, right? I say this, the first 100 years of biological research was driven by physics and chemistry. Biology was the cart. Physics, chemistry, and mathematics were driving the cart of biology. Now the cart can't move any further because these horses don't know where to go. Cart and horse have changed. Now you're beginning to make observations in biology, which is physics, chemistry, and mathematics cannot answer. The physics we know, the chemistry we know. So now people are saying, okay, what new physics do I need to find? What new chemistry do I need to find? How do I model this with the mathematical stuff that we have, right? They're related, but they're distinct.
Would you say then biology is trying to find its equilibrium right now as a subject?
I wouldn't say that. Biology's competition is engineering. Biology's competition is not physics or chemistry, right? Engineers use physics and chemistry to do things. Nature uses physics and chemistry to make life. They are the same. So I don't see a competition between physics, chemistry, and biology, right? There is a competition between engineering and biology. That's where the future of biology is. That so far, when I want to study a cell, I made a microscope with all my engineering knowledge, and I could observe a cell. Things that are happening in a cell that I can't do anymore. So I'm asking the question in reverse. I know so much about biology, and nature is so much more efficient. Why am I doing it this way? Why can't I do it the way biology does it? Nature is doing it this way. And then I ask, but I don't know how nature manages to do that. From all the physics and chemistry I know, I can build this. But biology is doing it much more smartly than me. There are many examples of this.
So when you study this beautiful, in some sense, you're back engineering the design of nature, right? So then in that sense, what would you call, or what would you say are some of the characteristics of this design? Like, so a lot of people call it efficiency. There's a lot of efficiency, or at least nature looks for or work towards efficiency. Or does that mean improvement? Does that translate to something else? What would you say are some of the characteristics that nature's engineering has revealed to you, which we can use whenever we do something?
I wouldn't call efficiency, right?
Okay.
Nature is extremely inefficient, except that it has had a 10 million or 200 million year lead over you. So we are trying to do in 100, 200 years what nature has had 100 million years to do.
Right.
It's extremely inefficient. As we understand more and more, nature has dead ends. It goes to dead ends, and then, a reverses and goes in a different path. A lot of them, right? And so now that we understand so much, can we now think about saying, how do I make nature better? That's a very funny way of thinking about it. Let me give you a real example, right? I want to build a road, a 1 mile road. Now it takes a long time, a lot of people. It's biology doing the work, right? Me as a person going digging, making tar. Biology is doing the work.
Yeah.
We're using the tools around us to do the work to build the road. So now I ask, and what is happening there? Is chemistry happening there? That is physics happening there, right? Building a road is both physics and chemistry and biology, because the biology is doing the work. I'm asking, this is stupid. Biology already knows how to do physics and chemistry. Can I now synthetically engineer, for example, a bacteria with all the right genes which can do all this, and go spray a bunch of bacteria along the place where I want to row the road? It will use the soil there, make the tar that is required, and secrete the tar, and it will solidify.
Yeah, I want to ask you one question. Sorry, Professor Lam. This now goes to using biology as a means to an end, because of
Correct.
what we know, right? As a means to an end. And then would you say nature also has an end that way? That nature has a goal that way? I mean, we human beings are different from nature. We're trying to, learn these things, do these things, and we have our own reasons, now make everything, the example that you gave. I totally get it. But does that, do you understand what I'm trying to ask? Like, does nature have this goal that it is then using us and improving upon us so that we can get there quicker?
I don't think nature has a goal. I remember, I think there is, as humans, we somehow like to believe that we are superior, and it's very convenient for us to think that there is a direction, that the world is going to some path, biology is taking us somewhere. I don't think that is true. It is just happening. It's like the dinosaurs grow very big and they ate up everything. They created a scarcity. There was an asteroid, there was an ice age, and all the dinosaurs went away. Life kept surviving, right? The way we think about life is to survive. As humans, will we survive? I don't know. But will life survive on this earth? Absolutely, right? Because we have created this self-replicate, nature by accident has managed to create this self-replicating idea. And that will continue. And it will continue depending on the environment and survive in that environment, right? There was no oxygen at all on the earth to start with. And there was still life. And then suddenly oxygen happened, right? It was very reactive. It could kill anything. And then nature managed to figure out how to use oxygen.
Right.
This self-replicating thing, right? Essentially, you can nature engineered how to do this, right? So you put it in an environment, it figures out an engineering process to do it. Except that it's not doing it in a thoughtful fashion. It's not doing it by design. It's doing by trial and error. Yes. You see the difference? The difference between how nature created things and how an engineer creates things is that bridge example, right? You tell them, I want a bridge, I want it for that, and you design for that, and you do it. Nature says, I'm going to build 1,000 bridges, and if one of the bridges will work, I'll keep that, and the rest will all fall apart. I don't care.
Would you then say this trial and error is another word for saying slow? And by slow, what I mean is this, that when it's building these 1,000 bridges, what is probably happening is seeing that the factors that can affect what I'm building are so many that just building that one thing, I do not know if it will live for 10 years, for 100, for 1 million. I want it to live for as long as it can. So let me do these 1,000 million trials and errors, out of which maybe one will survive, which will be the most, let's say, robust of my designs. And so I take my time. And so I do my trials and errors. But human beings, you're saying, are you also saying that these trials and errors, we are also speeding up that so that we know exactly what we are going to do, and then we can build things that...
No, we're not speeding it up, right? So this is, there are a number of words that you used, which are all very relative and fallacy, right?
Okay.
Time is a funny word. If you think of a bacteria and how quickly it evolves very, very quickly, right? That's because it replicates every few minutes. We human beings have a tendency to compare time with our lifetimes. And we say slow and fast based on our lifetime. So people say, there is a geological time and then there is a biological time. I don't think there's a geological time and a biological time. There is a human perceived time and there is a time that happens, right? So what you think is fast and slow is relative to your lifespan. We think if it happens in my lifespan, it's fast. If it happens in 5 generations, it's slow. Now think about the bacteria. It might say the same thing. If it's a bacteria had a mind, it would be saying the same thing. If it happens in my lifetime, it's slow. If it happens in 5 generations, if it happens in my lifetime, it is fast. It happens in 5 generations, it is slow. But it replicates every 3 minutes. So for it, 5 generations is 15 minutes. You see the fallacy. It is the relationship that is a problem. It's humans putting ourselves in the center of the earth and the center of the universe. That is the problem with this fallacy of notion of fast and the same speed.
No, I totally understand. We spoke to linguists and we understood how often and how much and how intensely language can sometimes fall short. But, what else do we have? Like, it's the best you can do to explain yourself to another person and still fall short. There's so many interesting points that you've brought up, Professor. I think the question that I would like to ask you now is this word evolution, since we're talking about language and how it falls short and everything. So for a biologist, it means something. It means many things, many specific things, many uncertain things, but the biologist is clear what it is clear about and what it is not is unclear about. Sure. But this is kind of seeped into the human, the public consciousness. We all use evolution of an idea, evolution of a startup, evolution of something. So what would you say in which the way we understand this word evolution and how commonly we apply it differs from what evolution actually is?
Evolution is a word that's interpreted by different people, as you correctly said, in different ways. But I think there is a common definition which people can converge to. And that definition, of course, makes it, provides it the flexibility. And I think this is a very Darwinian idea, right?
Okay.
So the idea of evolution was survival of the fittest. And therefore, you will constantly change in order to adapt to your environment, hoping that you can be the fittest. And they will survive, right? When we think about evolution of a startup, we're actually talking about the exact same idea. When you think of evolution of a language, we're talking about exactly the same idea. Today, we need words to communicate things that we do before the age of the internet, before the age of social media. And then there are cultural connotations, historical connotations, geographical connotations. And suddenly in the last 20 years, we have broken up geographical connotations. You can do something in a small village in Timbuktu, and 15 minutes later, it's tweeting all over the world, right?
Right.
So essentially, the geographical connotation is gone. So it's changing. So language has to evolve now to make sure that we communicate differently. Why? It's survival of the fittest. So it's responding to the environment for its own survival and being able to be the most fittest. So if you take that particular definition of evolution, that I'm going to constantly change and experiment to find out what is the fittest for my current environment, then it doesn't matter whether you apply that particular meaning of evolution to a startup or to language or to biology. It's still the same.
It's in a way we grasp it quite intuitively, and therefore we accept it without really describing what it might mean.
Exactly. When you do a startup, you quickly think, okay, if I don't do this, I won't make money. I won't survive. I need to raise money. I need to make this product. I need to tweak this. If I don't do this, no customer will buy it. If I don't do this, my competitor will have a better product. You're constantly sensing your environment and changing to adapt. That's what evolution's fundamental definition is.
Adaptation. So, okay.
No, it's not adaptation, right? It's sensing the environment and creating change. Adaptation is a slightly different word. Adaptation is. So where are you in? Where in India are you? I should have asked this question before because I can use the correct word.
Pondicherry right now, South India.
Okay, so if you think in Tamil Nadu, right? I don't know if you speak Tamil, but I'll tell you the Tamil word for this. It's called paravaila.
I don't care.
That's adaptation, which is let's compromise and figure out a solution. Evolution is not that. Evolution is changing to continue to survive, right? Adjusting and is different from change. Adjusting is I'm not going to change, but I'm going to give up something.
Compromise you're talking
Evolution
about.
doesn't like to give up something, right? Right? You see the difference?
Okay.
Adaptation is what I'm going to give up something and you're going to give up something and we make a compromise. That becomes adaptation. Evolution is I'm going to change so that I will respond. I'm hopefully responding correctly to my environment.
Because in the case of the compromise, there's change happening on both parts.
Both sides, exactly. So if I'm a startup, I cannot say, well, some other company has a better product. I'm going to slightly do something and hope the customer will buy my slightly worse product. That's not normally how it works, right? The customer has two products. This is better, this is worse. Both are the same cost. I will buy the better product. I have no influence.
Is there anything you'd like to add to it, or should I just carry on?
It's okay. Keep going on. I mean, otherwise,
yeah. Yeah, there's no ending. Yeah.
I want to let you lead the questions rather than be doing a monologue.
Okay. But please feel free to just resolve everything that you would like to say. Only then, it's valuable. In your, it's only then it's complete. I watched your TEDx talk, very, very interesting. And there in the introduction, you had written that it was written that you believe that science is a social concept. Right. So we had another a mathematician over. She was the first person we interviewed who also believes the same thing. And she, had her things to say about it. I'd like to know from you, what do you mean by this social concept? If science was, this idea of science being a social concept was how it all started. If so, then did we lose our way somewhere along the line of our path, our progression? And in bringing science back into the idea of science as a social concept back, what are we gaining?
So science is a social concept, continues to be a social concept, but like all other social concepts, things change, right? So science has changed with respect to the environment and the time it is in. So science as an idea is also constantly evolving. Science was at some point of time considered this esoteric thing. If you think about 1,000 years ago, like in the Indian context, for example, the king would patronage this person, and that person would do whatever they want to do, and that's how science was. And I think the change, and that the same idea of patronage and science has been the phenomena even till now, very recently. Instead of kings, it's the governments that fund science, right? Or philanthropy that funds science. So to me, where science is going to change in the social context is, well, it went from a king to a government funding basic science. And then we had Vannevar Bush, who said science is very important. And if we thought science, you can build the atom bomb, we built the atom bomb. And all of this happened. I'm not, so even how science is perceived by society has changed. But what has happened over the last 25 years with social media, a slightly interesting phenomena. And now science has to adapt to that phenomenon. And it was perfectly okay till 25 years ago that scientists published their work in these esoteric science journals. Other scientists read it and figured out, okay, hey, if I take this scientific principle and this scientific principle, I can make a new product or I can cure a new disease. That will help people. It was a group of people who were interacting with each other, who were doing things with each other, and they communicated with each other, and they had their own language for communication, full of jargon, and it worked very well. What has happened with social media is that anybody can get any information. So now you go and say, you know what, I want to know what interesting new things are happening in an esoteric area of science. You can go click in Google Scholar, find the paper, and you try reading it. You don't understand anything.
Yes. Yeah, they're not my primary source either. Right.
So now what happens is, earlier, this you couldn't do 20 years ago. So scientists never cared to communicate that way.
Right.
But now it's available for everybody, right? You wouldn't spend, even today, an issue of science is $8. You're not going to spend $8 and buy a science magazine to read jargon. So it was read only by the group of people who wanted to read that jargon. No, that's not true, right? True. Everybody wants to read. Now, when I begin to read it this way, I'm saying, why is it this is written with so much jargon? And me as a taxpayer, I'm paying for it. And I don't know why what this person is doing using my tax money. They're communicating among themselves and not communicating with me, and I am paying for this. Science has always been a social thing, but the social context changes. Science has to change its approach. Now, science is in a very interesting place that it has to think about Not how you do science. Even that has to change, and I'll come to that in a second. But how you communicate science. Because people are beginning to ask, tell me why. When you didn't know as public, you gave the money to the government, and the government said, okay, I don't know. I'm going to have a group of people who know how science is done. They're going to then decide how to make science progress and fund them and decide how funding happens. Right? That's so just perfectly okay. And I, as the person whose money was being used, as a common man whose tax money was being used, was two-step removed. I gave the money to the government appointed some authority, which then decided how to go. But now I have direct sight of what the person is doing. And I don't understand the process. And the process is not communicated to me in a way that I understand. Or the result is not communicated to me in a way I understand. So it's unsettling to me, right? And the polio vaccine came. There wasn't an anti-vaccine movement. This is a scientist who has discovered it, a doctor who is giving it, nobody questioned it. Because nobody could go read the paper and understand, because the paper was not available for them. Now it's available and I can ask questions. This is happening even with technology. But there is so we need to change in how we communicate. We need to change in how we do the process of funding science. Interestingly, normally you would think a small group of people who have a self-interest in preserving themselves will adapt faster than the environment, right? The environment of 6 billion people, let's assume there are 1 million scientists. You would think that 2 million people say, I'm going to very quickly adapt to the outside world, right? And you would think these are the smarter people. So these smarter people instead have taken a different approach, which is, I'm smarter than the others, so I'm going to try and preserve my ivory tower. I'm special. I'm more educated. That has resulted globally in India, in the US, in Europe, and a backlash against intelligentsia and academia, right? And the backlash is completely reasonable because you did not respond to this environment.
It won't change and things will go on as they're going. And
no, it's not even that. It's that. That is laziness. This is not even laziness. This is a complete sense of
an elitist mindset.
Elitism, right? I am so special. They have taken a different approach and said that, look, but if I don't discover new things, you won't have new products. Yeah. So I'm special. This was okay for a long time. But today people are saying, no. Think about this differently. If I don't pay for you, you won't do squat. You're using my money and doing whatever you want.
And would you say even in terms of general intelligence, maybe they're able to ask questions and scientists are like, okay, we are not the only intelligent people around or one of the most intelligent ones around. People can ask.
No. Scientists are not anywhere the most intelligent people. Intelligence is a funny word, right? Just because I know more of jargon in the narrow area does not make me any more intelligent than somebody else. But that is what academics and scientists are. I have a PhD, I have a master's degree, I'm doing research, I'm doing something esoteric, I'm so special. What social media has done is taken that shell away, right? Of you being special. No more, the balloon doesn't have an envelope anymore. It's been punctured, it's full of holes. Everybody can go see what is happening inside because of social media. And they realize it's not really special. What do we do in my lab, for example? On an average day, we do 10 experiments, 9 of them don't work. And then we say, okay, why did this not work? Why this worked? And say, okay, now what is the next set of experiments we should do? And if you're that smart, the next day, all my 10 experiments should work, right? It doesn't. Still 9 experiments don't work, only 1 works. So if I'm smarter, it's a different idea. So I'm doing trial and error. But think about, most people are doing exactly the same thing. And they realize, except that these guys are doing something in a very esoteric place. I'm doing something in a not so esoteric place. And therefore, there is no reason for them to be any more special than me. The globe has realized, but as scientist, I still think that I'm special. I still think I'm right? Now, there is this clash that is this anti-elitism. So now, again, evolution is going to happen, right? Which is, you're going to respond to the environment. You're going to be able to communicate science better. And like you are helping do that, right? Tell people what real science is. Explain that to them. Break the jargon down. The support for science will come back. Once people appreciate what it is doing. The support for farmers hasn't gone away. The support for policemen haven't gone away because, even though we know what they're doing, right? So support for scientists won't go away. Scientists have to change to be able to communicate.
No, this reminds me of what Mr. Steven Pinker also says. He is very much into making sure that the papers that are written are not written so that their readership is limited, that they should be written in a way that can be understood by people, because we are talking about things that matter to everyone. Maybe not all the things that you do in the lab matter to everyone, but there are certain things that, might have a direct influence on people. So, yeah. So this brings me to another question. In the same TEDx talk, you gave the example of the Pacific beetle cockroach and how its milk is good, and you propose something very different and something I'd never heard, which is that because it will outlive us, our history should somehow be encoded in it, and the future generation, whoever would, I don't know if that was a joke, that was a projection, and you're really thinking out loud these things. But then the highlight of that story was the feedback that a journalist gave, a critic gave, who said that, come on, go do some real science. You said that was the minus. Okay, good, whatever you're doing. But this doesn't make any sense. The kind of experiments you're conducting, go and do some real science. And then I started to wonder why this would have happened, because there is have you seen this film Interstellar? It came out in 2014. You've heard of it?
Yeah, I heard about it.
No problem. I'll try to build the context here. So what is happening is something called blight is threatening survival of the species on the planet. And so everybody all over the planet, people are trying to cope up with it. The regular man, they're cutting educational budgets and, trying to make sure that everyone becomes a farmer, and there's nothing else that you can do because you need to grow more food. And then there are the scientists, right, who are trying to build these spaceships and whatnot, that they can send a bunch of astronauts out into space, look for a new planet for us. So now this Matthew McConaughey's character, he comes in, and he's talking to one of the chief engineers of this whole operation of sending people out into space. And he says, sir, why are you doing all this in secret? He says, because public opinion does not allow for government funding to go into this when you are not able to put food on your table. Do you see the point being that, so the experiments that you're conducting in your lab, and then the people, you're trying to bridge that gap through language, through communication and everything. But the fact that critic would respond that way, the way he did, that this is useless and go to real science, could it be because you are at maybe on a daily basis, maybe on a weekly basis, more at the threshold of something like a breakthrough, something new coming out. So you're always at the edge, and you're also pulling your hair out, but your experience is intense, no matter what. It's an intense experience. To the common man, that in the intensity of that experience, I don't know how much it is available, how much it is, right there on a daily basis. So maybe that lack of being on the edge, right, makes us not see the importance of what is being conducted. The cockroach milk sounds trivial to me. You put those words together, no, I'm not buying it, because I'm not able to see the beauty that you're able to see. And so do you think this is the place where some critics can come from?
Maybe my TED Talk is not as good as I thought it was, because the critique did not come from, the critique actually did not come from the common man. So after we published the paper, right, the response from the public was fantastic. The critique that you should go do real science came from scientists. It came from scientists who said, this area of biology has no interest. Nobody is interested in a cockroach. These guys who have done these fantastic sort of experiments should go and spend time doing more interesting science, more useful science. That comment did not come from a common man. It actually came from scientists who reviewed my paper. This is the problem. This is the social difference, right? Because I communicated my science in a way that a common man understands. I said, look, what we see here is something that is so nutritious. Mm-hmm. This cockroach just evolved, the specific species of cockroaches evolved to make one of the most nutritious things in the world. They are going to outlive us, right? And they're going to do so many interesting things. So that was a science that we did. But when we submitted for publication in a scientific journal, comment to us, this is all great, but this is not real science. You see, the critique did not come from the public. The scientists thought, you're just you're writing it in a way that will be interesting to the common man. There is no real science in this. Big deal. Cockroaches have crystals and they have nutritious food. So what? It is completely shocking. You can Google up. As recently as a few months ago, in Cuba, they have a crisis for milk. And a Cuban minister says something completely stupid. He says, well, maybe we should stop growing cows and grow cockroaches. Cuba's milk problem would go away. I'm not saying what the minister said was right or wrong, but the fact that that message reached a minister who you would in Cuba, right? So they understood the importance of what we were doing. The comment saying that this is not good science came from a scientist. So scientists are so wearing blinders that they can't, and they're convinced, and they are in this little, they become this own self-replicating species, which has its own set of rules that somehow they think that they don't have to follow the laws of the world around them. Right, this is a crisis in academia, and I struggle. I try to communicate with this every day to my colleagues at Purdue, to my colleagues all around the world. There are a few of us who think this is what we should do, but I think it's very hard. I mean, what happens with any species, right, is the same. Your self-preservation becomes much more important than saying I can change in order to adapt and be different. I just try to preserve. That instinct of self-preservation takes over. And it's very detrimental. This is the same idea why fanaticism happens. We somehow want to preserve and not change, right? So whether it's in a social, so the same thing that's happening to religious fanaticism is what is happening, and I call this scientific fanaticism. That's the only thing, right? This is where we are with science, and I think this is to change, and people have to think differently and say, yeah, my religion is good, but my religion has to adapt to time. Right. My religion has to change. The world has changed. You can't go back. Right. I can't undo social media.
So when people who find it difficult to change, scientists especially who find to change their beliefs or the way of looking, they must be finding some value in saying no to the change. What do you think their reasons are to deny the change that people like you see to be very obvious?
It's not resistance to change. It is just it's Newton's first law, right? Everybody like to be in a state of inertia or in constant motion unless an external force is applied on it. That's all. So it's just inertia.
So you think it's habit? It's just habit that's keeping them there?
And it's very happy. This is how I know to do it. And then you keep repeating it yourself and you say, this is the correct thing to do, right? And scientists think the way we are doing, and also you should remember historical context, right? If you think about the last 100 years, since Industrial Revolution till today, the rate at which scientists progressed is constantly increased, right? It took a long time for 1 million people to go on an airplane. It took less than 2 days for 1 million people to be on Twitter. And the scientists take credit for all this. Fair, correct, truly, right? I mean, I'm not taking the credit away from them. That's fantastic. So they're convinced that the way they do and what they do is the correct way because it is actually delivered. If you think about 50 years ago, somebody with cancer had a much shorter lifespan than somebody today. If you look 200 years ago, the average lifespan was 40 years, and we have constantly doubled, right? And if you think about, this is what I said in the TED Talk as well, right? So since you brought it up, Malthus said that we will now not have more than 1 billion people, and scientists figured out a way to have more than 1 billion people. According to this group, look, we have delivered. So we know what we're doing. So why are you now telling me I should do it differently?
Right. But then would you say that the way they've delivered, that there are no holes to poke in it?
I don't think it is holes to poke. What worked the last 100 years is not going to work the next 100 years. You're not responding to change outside. I don't think it's a hole to poke. This is evolution. Since you started using the word in another context, I'm using, this is evolution as a community. Evolution as what the world expects. You have to respond to the community and adapt to change.
Okay, let me explain. When I say holes to poke, what I was trying to say is this. So the scientists delivered, and as Malthus had predicted, we would not have it. They proved it that he was wrong by delivering. That's what you meant. But in this delivery, in having 6 billion people on the planet today, because their generations were able to survive and procreate, are there no problems with having proved Malthus wrong? Are there no problems that we, got in our way in having done that? Like there are people.
There is. Yeah. So again, the progress is a definition that you make, right? It's a definition. So for example, I'll give you a very simple example. My father-in-law and mother-in-law are 80 plus, and they just came to live with us because we're old, right? We have a kitchen tap in our house, which when you touch, water comes. When you touch again, water stops. And it's very nice because if I'm cooking, I have a vessel, I want to open the tap, I can touch any part of my body. Brilliant, great innovation, great progress. They were very happy with it. And then one day, remember, something like that also runs on energy. And I was not at home, and they're hitting the tap, they're touching the tap, they're slapping it, water doesn't come, right? So the battery that controls that is dead. They never realized that, oh, there is a battery, it has to be changed, because we didn't talk about it. They took it for granted. Now, according to them, this is a stupid innovation now. In olden days, when we could open the tap physically, it never went wrong.
Yeah, back to the basics things. Yeah. There's no battery.
What is right, what is wrong?
Yeah.
What is innovation?
Yeah.
Is a perception. What is progress? Is a perception in your head. So your question is a very rhetorical question. I mean, you're questioning the idea of what progress is. And my point is it's very subjective.
Because no matter the progress, it'll have its pros and cons. Exactly. And it'll always have something else to compare it to. It's especially what has happened in the past.
So as humans, for us, our species is more important than the rest of the world.
Yeah,
so
unfortunately.
We have defined progress as more of my species.
Our species. And then when we define progress, what are we? So when we have a touch sensitive tap, it's comfortable. So what are we doing? So we are we trying to save time so that the time that we save, we can devote somewhere else? Is that what progress is? Are we calling progress something that makes our lives more comfortable? And then that's not the end of the sentence, I'm sure. So if your life becomes comfortable, then what? So the definition of progress, one is we clearly understand is pros and cons. Everything will have. Today we have touch screen. Tomorrow you will say, turn on the tap. The tap will turn on. And you might forget something that when it doesn't work, you might not know why it doesn't work, right? So pros and cons is one characteristic of progress. Why else do we want progress? Like for comfort, but comfort, then I think you got my point, what I'm trying to say.
Yeah, I mean, this is a philosophical question. You're asking a scientist the wrong question, right? I really don't know the answer to your question.
Is it science a way of looking, Professor?
No. I mean, I look at this. I mean, so what I'm saying is, I'm saying things in an area where I don't have great expertise in, right? What you're asking is a very philosophical question. What is progress? What it should be? And really, all of that is debatable. And I look at it very differently as a scientist on a day-to-day basis, right?
Sure.
The reason for me to switch from physics to biology was also the same, right? I'm naturally a curious person. What wakes me up every day is I just need to know how this is working, how this is happening, why this is happening, and why I can't do this, right? It is that I make an observation, I see something, and I just want to know how it happens. I find out how it happens, and then somebody uses it for something else. I'm really not relating myself to 10 steps forward. My motivation is very internal, right? My motivation is, today I want to do this experiment and find out if this experiment, what does this experiment say? And why is it saying that, right? I'm not asking if I find this and I find this, and if I find this, will I cure cancer? Will I cure Alzheimer's disease? Or will I change the world? Will the world be a better place? The definition of progress for me is very simple. How long can I do this? How happy will I be doing this? If I'm unhappy doing this, I should stop. So everything in my world revolves around that one thing, what keeps me motivated. But then what keeps you motivated could be very, very different. And therefore, progress as a definition is a very difficult answer, right? And my in-laws don't understand. They retired at 60. I'm thinking of changing my career. I'm 58, and I'm saying, in 2 years, I'm going to do this, and I'm going to change my career and start something new. Don't you want to retire? He said, no, I have time to rediscover myself. So you see, it's a very funny world. They said, oh, I'm just relaxing. I'm so happy. I don't have to do anything. And I'm saying, I'm already happy.
Even from what you're saying, there is something, if I dig in deeper, let me go back and see how I can strain what's going on in my mind. We were talking about how certain scientists want to keep it where the bubble alive. This is where we do things. This is where we keep things. What we choose should go out, that goes out, right? So it's a code between us. Now, that elitist mindset, right? Now, okay, let's keep it aside. Now, when you're talking to me about your curiosity, right? Now, your curiosity makes you very focused. You are able to, let's say, even if you're sitting, if you're driven by curiosity, you might be sitting on a chair which is uncomfortable, but you don't realize it. And you are, you just go on doing what you're doing, right? Curiosity has allowed you to bring your focus into such, define your focus so strongly that probably is what an elitist mindset is, perhaps above and beyond anything else. The fact that we are able to overcome certain shortcomings inside us and use the strengths that we gain to create something useful. Did you see what I'm trying to say? Maybe it's valid.
I understand what he's saying, but I'm going to change the context of what you're saying slightly differently and bring in biology back to biology, because I don't know how much time we have. I have to leave at 11:15, so I have another half an hour, but I want to bring in biology back.
Sure.
This is just biology, okay? The idea that what pumps adrenaline into me and makes me feel good could be very different from what pumps adrenaline into you and makes you feel good. So to somehow say only scientists do this for happiness is a very wrong thing. I have friends who are doctors, surgeons, who would rather do surgery than do anything else, right? And they're very happy. If they don't do surgery, they feel like they're dead. I have physician friends. I have engineers. I have a friend who does, in the last 20 years, he has only been doing this green farming. He has his own farm. It is zero input, zero output. He's completely self-sustained. He's very happy every day in the morning. And he's so excited that, hey, in the last 10 years I've been doing this. I've gone from taking 20% from the grid to now I'm only taking 3% from the grid. That's his measurement of his success. That's measurement of his happiness. Yeah. His drive, what flows, the adrenaline flows in his body that makes him happy is this idea that he's not taking anything from the grid, right? So I'm neutral. My 20-acre farm is completely neutral. Nothing leaves my farm. No waste goes out. Nothing comes in. I'm living with nature. Now, that's very different from what I'm doing. Now, so to believe somehow that you do something that you like, you're elitist, is a poor idea, because that's what a farmer is doing, or a lot of people. I mean, I'm not saying everybody does this, right? A lot of scientists are unhappy too. So that Gaussian curve of people who are doing it for happiness is different. So a farmer who's doing that is also happy. That's what's adrenaline. Why is he or she not a elitist, right? Why is a mother who takes great pleasure in taking care of their children not being elitist? Why should a scientist alone be elitist? So I don't understand the biological context. The biology is very simple. What makes more endorphins makes you feel good. And what allows more endorphins in your body could be very different for you, me, or somebody else. That doesn't give you a cause to be elitist. I'm sorry. That is privilege speaking. You understand? That's privilege.
And if people think that it's well earned, that makes it.
Yeah, exactly. That's privilege, right? I don't think there is the idea that I am able to therefore go through hardship of not worrying about a chair or not doing anything in order to do this is really a matter, because many people do that in a variety of contexts who don't do research at all.
So would you say that there are the human species as it is evolved, emotionally we have evolved, mentally we have evolved, that we have brought into the world certain ideas that might not be found in other species. And that if we go, those ideas go away with us. And well, that's not really the point of that's not what I want to say. But that there are certain ideas like elitist, from however you have defined it, it seems, would you say that it does not exist in the species, any other species other than ours?
No, that's not true, right? That's not true. The elitism is there everywhere, right? You think about the alpha male in chimpanzees. You think about the lions, right? The idea of elitism exists everywhere.
Territorial, right? So territory, keeping your territory. So territory can be knowledge. Territory can be physical strength. Certain traditions you don't intermarry in certain traditions. You keep it to yourself, right? So then.
So that's what I'm saying. So that's not specific to humans. That is a evolutionary drive to protect yourself, right? And that's okay. But if I'm a scientist and if I'm supposed to be smart, I should understand that, right? And I should not be swayed by this kind of biological context and be rational.
But what if they say we're just trying to protect ourselves, and that's evolutionary?
Exactly. So what are you doing? You're succumbing to the same laws that you know are not going to work against you, right? So to somehow say that biologists are smarter or a scientist is smarter is a very poor thought process, because you know as a scientist that this being territorial, being a group, being a clan, being protective is actually not good for you. There is enough evidence around you, and you still do it.
And would you say there is a biological explanation, or do you think this is a philosophical idea again, that why do we have affinity to certain kind of ideas so much? Is it natural? Like in religion, you see certain affinity to certain kind of ideas. Here, scientists they're unable to the elitists, say, for example, are unable to let go of certain things. This affinity it's like, for the lack of a better phrase, woven into the DNA or something. What is it? But it can be.
I think it's the preservation of species is very ingrained in the survival of the fittest idea of biology, and you would do anything for that. And that's why you see, even among animals, even among many species, they hunt as a group. Right. They live as a group. Right. Why do they do that? Because they know one of us die, the rest will survive. And there are many species, people have seen that, right? If there is a few young ones and the mother dies, the other species, other group will take care of them. Right. So the idea of survival of the species is a very common thing, and we do this. And except that, we have classified humans as one species in biology, which is completely true. But we have subdivided ourselves into, I'm a scientist, you're an engineer, you're a doctor, you're a farmer, you're a lawyer. Now we each just become its own
ecosystem.
I like this jargon that the legal system has come up with this. You become an entity, or you become a person, and India has recently said nature is a person, right? So what we have done is we have created entities. There's an association of chartered accountants, and they say we should not have any more chartered accountants, because if you have more chartered accountants, my value will go down. People will pay me less. No, I'm not. That's true, right? And now, and so every group you form becomes this entity which wants to preserve itself. That's not true for scientists alone. Except that, as a scientist, I know that self-preservation is a poor idea. It's not going to do for long-term survival. Therefore, I should actively, at least, a chartered accountant doesn't understand the nature's force of biology, and therefore it's not good. Whereas I understand diversity is important. So I should be more welcoming to it. But if I behave like any other group in any other species, I'm no better. Yet I say I'm better. Yet I say I'm smarter than everybody else. That is the problem I have.
Right. Professor Ramaswamy, I think on that note, we can end up.
Yeah, I'm sorry, this was not a biology discussion. It became more a discussion on scientists and philosophy. But
no, I think the biological basis for all things that happen is the talk of life.
Yeah, absolutely. You see the drive, right? Why a child accountants don't want more child accountants? My value is gone, right? When India had only 5 IITs, and the government said we're going to make more, you saw the protests that IITs did. Our value will go down. So this is nothing special.
Anything that comes about will go through this process.
Change is hard. We don't like change. That's Newton's first law.
Change is hard, truly. So thank you so much, Professor Ramaswamy. This was so interesting. And I think we took a nice deep dive into many things, many aspects, biology, otherwise.
This is not what I expected the conversation will be about. So good, I had a good time. Thank you very much, Disha, for that.
Okay. Thank you, Professor.
You're welcome. Thank you. Bye-bye.
Speaking with Professor Ramaswamy gave us a new way of thinking about what biology is, along with a deeper insight into the workings of nature. It is indeed profound knowledge that a small accident led to the creation of all life on Earth, and the ingenious ways it discovered to march forth in diverse forms despite the odds stacked heavily against it. It will be wonderful to know your thoughts on the conversation, and if it inspired your worldview in any way. Thanks for being here. I will see you soon with another interesting mind demystifying another interesting subject. Until then, take care.